All right, page 135, function operations. Today, I'm going to show you how to add and subtract functions and how to multiply and divide functions.
Yay.
And really, you know how to do it. It's just the notation that it's given to you in. If I didn't show you and you saw it like on FSA or something, you may be like, what in the world is that even talking about? But after I show you the notation and what it means, easy peasy. Okay? It's going to be easy peasy. So I'm going to let f of x equal 4x plus 7 and g of x equals the square root of x and then plus x, and that plus x is not under the radical sign.
What is g of x?
It's just a different name for a function. Like I could have h of x, f of x, g of x. It's just notating a function. Okay? So like I would call this function f and I would call this function g. Alright? So if you're asked, what is f plus g? And then what is the domain? That's just asking what is function f plus function g, okay? You might see it written like this, f plus g of x. I don't like it written like that. It confuses me. Whenever it's written like that, I like to rewrite it as f of x plus g of x. F of x plus g of x.
And then just add together?
Yep. So what is function f equal to? 4x plus 7. Plus, what is g of x equal to?
Square root of x plus x.
Can I just add those together? Yeah. Are the parentheses important in this case?
No.
No. So I really don't need them. So I'm just going to rewrite this. Bless you. Without the parentheses. Now the highest degree is a 1. We also have a radical in there. We have a constant. Sometimes on these you might like, how do I write this in standard form? Well, you have the x and the square root of x, so it's not that important. But if you have x's, write those before the constant. At least put the constant last. If you have any like terms, combine them. So can I combine 4x with anything?
With x.
So 4x plus x is,
5x.
and then I would probably put the square root of x next so that I could write the constant last.
Put the square root of x first.
What?
Put the square root of x first.
You can put the square root of x first.
Where is radical supposed to go in standard form?
That's what I'm saying. Like, no, just put the constant because our degrees are the same. Well, really, if you think about it, x has a degree of 1. X's exponent's a 1. This x's exponent's 1/2.
So
Right?
should we go after the constant?
Well, isn't 1/2 smaller than 1? No, this has a degree of 0,
Oh. Yeah.
right? So, we'll go with this. So, my last class said, well, should you write f plus g of x in front of it equals? You may see it like that, or you may just see it as 5x plus square root of x plus 7.
Wait, that's the new
Yep, here, we're not solving for anything.
Oh.
I just simplified as much as I could. Yeah. Let me talk about the domain of f and the domain of g. So the domain of f is what? If you just talk about f all by itself, it's going to be a line. Are there any values that I can plug in for x that aren't going to be possible?
No.
No. So our domain would be
Oh, I don't know.
all real numbers. What about the domain of g? Anything I can plug in for x, it's not going to work.
Yeah. Any negatives?
No negatives, right? Because G has that square root of x. This x is okay. If it was just this x, we could have all real numbers. But when we take the square root of a negative, we're going to get an imaginary number, right? Which is not on our graphs. We're just using real numbers on our graphs. So G, the domain, is all real numbers greater than or equal to 0. So all real numbers greater than or equal to 0. But when we're talking about the domain of f plus g of x, when we added those two together, is its domain going to be all real numbers? Or all real numbers greater than or equal to 0, or something different?
Greater than or equal to 0.
All real numbers greater than or equal to 0. So when you looked at them separately, f's all real numbers, g's all real numbers greater than or equal to 0. When we added the two, what did we get? We can't get any negatives because we have a variable under the radical. So when we added them together, the domain of our answer is all real numbers greater than or equal to 0.
So for the domain of G, could you put all the natural numbers?
No, because natural numbers are like counting numbers, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So that's counting numbers, right?
Oh, wait, what'd you ask for the domain of what?
Of G.
Of G. Oh. We would put whole numbers, actually, because natural doesn't include 0. You can do that. All right, let's do f minus g. So you may see that as f minus g of x, which again, that's confusing to me. Why do they just put the x with a g? I don't like that. So I would rewrite it as f of x minus g of x. So again, we're using the same function f and function g that we did for the first problem. So function f would be, and this time parentheses are going to be important because I'm subtracting function g, right? So f of x is 4x plus 7 minus function g, open parentheses, square root of x, and then a plus x that is not in parentheses.
So you distribute the.
We're going to distribute the negative, which in my first parentheses, that doesn't matter, right? Distribute the negative, so that would be minus square root of x minus x. We're not solving for x. This is not an equation. We're just simplifying it as much as we can. 4x, can I combine anything with 4x?
Yes.
The minus x, right? So 4x minus x is 3x. And I'm going to put minus the square root of x next, plus 7. What's my domain?
All real numbers greater than or equal to 0.
All real numbers greater than or equal to 0. Again, we have that variable under the radical. Coolio? Pretty easy, right? Page 136. Let f of x equal 4x minus 1 and g of x equal 2x squared plus 3. And I'm going to find my first example, f plus g of x. And that's different than you saw me write it over here. Still means the same thing. I still don't like it written like that. I'm still going to rewrite it as f of x plus g of x. You don't have to. It just makes more sense to me. So I'm adding function f to function g. Are parentheses going to be important?
No.
No, not when I'm adding. Is it even necessary for me to write them? No, you can if you want to. I'm not going to when I add them. So f of x is 4x minus 1. And then I'm adding function g, which is 2x squared plus 3. Is that as simplified in a standard form as I can get it?
No.
What should I write first?
2x
2x squared
plus 4
plus 4x.
plus
Is that as simplified in a standard form as I can get it? Yeah. There's no need to factor it or anything like that. So when I add those two functions together, well, first of all, what would be my domain just of function f? All real numbers. What about function g? All real numbers, right? So what about when I add them together, what's my domain of function f plus function g? All real numbers. You really just have to be careful when there's a fraction or when there's a variable under a radical, okay? Right off the top of my head. And what we'll be dealing with in our notes today, that's when you have to think about, okay, is the domain anything except for all real numbers? All right, how about this? Let's find g minus f of x, which basically means function g minus function f. Parentheses going to be important in this one? Yes. So function g is 2x squared plus 3 minus function f is 4x minus 1. Obviously, I'm going to have to distribute that negative sign, right? So 2x squared plus 3, nothing to distribute yet. And then minus 4x plus 1. So maybe any questions about anything you've seen so far? Pretty easy. Am I in standard form?
No.
No, close. What's going to be my first term? 2x squared, and then minus 4x, and then plus 4. Because I had a constant of 3 and 1, that makes 4. What will my domain be? All real numbers. I think this is a good move. Okay, let's get crazy up in here.
No.
It's not really that crazy. It's not really that crazy. Let's find f times g of x.
Same numbers?
Same function f, same function g. F times g of x. Again, I would say f of x times g of x. We got this. So function f is 4x minus 1. Parentheses are going to be important. Do we need a plus or a minus in between the parentheses? No, because we're multiplying it by function g, which is 2x squared plus 3. Can we multiply two binomials together?
Yeah.
Yes. This is not our first rodeo, right? Is that difficult? No. 4x times 2x squared is 8x cubed.
So cute.
cubed, x times x squared. 4x times positive 3
12x.
plus 12x. Negative 1 times 2x squared. Negative 2x squared. And negative 1 times positive 3. Alright. Is it in standard form?
No.
No. Do you have any like terms? No. So let's just write it in standard form. What comes first? 8x cubed minus 2x squared. Hold on, I gotta change my colors. Plus 12x minus 3. We really got crazy, didn't we? Yeah. What's my domain? All real numbers. You can write all real numbers. I really love the double R. Negative infinity to positive infinity. Remember that? I like the double R. That's not a very pretty double R I just made, but. Alright, I'm going to fit one more on this page. This time, we're going to divide my functions. I'm going to do g divided by f of x. Now, if we hadn't learned this lesson today, you might look at that and be like, what in the world is all that? We all know what it means now. Function g divided by function f, right? So function g is 2x squared plus 3 divided by function f is 4x minus 1. Can I factor the numerator? It is a quadratic. A would be 2, B would be 0, and C would be 3. So two numbers that multiply together to get AC, that's two numbers that multiply to get 6, add to get 0. Is that possible? No. If I could factor it, I would though. Okay? So I cannot factor the numerator. Is the denominator factorable? No. If I could, I would, but I can't. So this is my answer. It's not always just going to be like that. A lot of times you're going to have to factor. But my domain, think about your restriction. Is this domain going to be all real numbers?
No.
Close. It's going to be all real numbers except what? What would turn that denominator into a 0?
0.
4 times 0 is 0. 0 minus 1 is negative 1. How could I figure it out?
Set equal to 0.
Set that equal to 0, right? We knew that over here on the side. 4x minus 1 equals 0. Add 1 to both sides. 4x equals 1. Divide by 4 and x equals 1/4. So let me prove it to you. If I had 4x minus 1 and x was 1/4, that'd be 4 times 1/4 minus 1, which 4 over 1 times 1/4 is 4/4, which is 1 minus 1. Isn't that 0? Yes. So since we can't have 0 in the denominator, that's the only thing x cannot equal is 1/4. So all real numbers except 1/4. Basically, it's my restriction. When you have a fraction, look at where your restriction would be. Oh, yes, I'm sorry. We're almost finished. Two more examples coming at you on page 137.
That's it.
Let's see. I don't know. Maybe.
No. I briefly.
Go one. Y'all finished with this page? All right, page 137. All right, we're changing our functions. This time we're letting f of x equal 3x squared minus 11x minus 4.
Oh my god.
And we're letting g of x equal 3x plus 1. First thing I'm going to do is we're going to do f times g of x. This time I have in parentheses. Last time I didn't. You're going to see it in different ways. I'm going to rewrite it. That means f of x times g of x. Look at function f. What's our domain? All real numbers. And function g, all real numbers as well. Let's see what happens when we multiply them together. Let's see what our domain is when we multiply them. Okay? So for function f, that's 3x squared minus 11x minus 4. We're multiplying by function g, so parentheses are important, no sign in between. Can't we do this? Yeah. It's a lot of multiplying, but multiplying. So 3x squared times 3x, 9x cubed. 3x squared times positive 1. Negative 11x times 3x.
33x, negative 33x squared.
Negative 33x squared. Negative 11x times positive 1. Negative 4 times 3x.
Negative 12x.
And negative 4 times positive 1. Negative 4. All right. What's my highest degree?
9x
Cubic, cube, 3 degrees, right? And I only have one of those, so we know that's going to come first. 9x cubed.
We can have my term.
I have my quadratics. Combine those, and what do I get? Negative 30x squared. I have two linear terms. Combine those, and I get... And then just one constant, don't forget about it. So I've got a cubic polynomial of 4 terms. What is the domain? All real numbers. Let's divide. Y'all okay with this one? Quite easy. Easiest thing we've done since quadratic formula. It's easier than that.
But it's tedious.
Tedious, yes. All right, how about this? F divided by g of x.
Same numbers?
Same function f, same function g as the last time. So I'm going to rewrite it as f of x divided by g of x. Function f is 3x squared minus 11x minus 4 divided by function g, 3x plus 1. Can 3x plus 1 be factored? No, it's a linear binomial and it doesn't have a GCF, so that would be our only option, right? But our numerator is a quadratic trinomial. We might be able to factor that, and if we can, we have to, because if anything can cancel, then we have to cancel it. So I'm going to do that over here on the side. And this will be an old dividing slide, and we haven't seen one of those in quite some time. So A is 3, B is negative 11, and C is negative 4. I need two numbers that multiply together to get AC. A times C is negative 12. And then add together to get B, which is negative 11. Negative 12 times positive 1 is negative 12. Negative 12 plus 1 is negative 11. Boom.
It's almost there.
So it's almost there. You're exactly right. So if x minus 12 and x plus 1. Are those my factors? First times first, x squared. Is that my first term? Last times last, negative 12. Is that my last term? No. What do we got to do? Divide and slide, right? We haven't done that in a while. We forget about it. So if a is any number other than 1, we got to divide or slide. Sorry to bother you. All right, 12 thirds, divide or slide.
Divide.
Y'all got this. Divide, because 12 divides by 3 evenly. 12 divided by 3 is 4. 1/3, divide or slide. Slide. Now remember, if it's a slide, before you slide, if you can reduce, you have to reduce. Can you reduce 1/3?
No.
So slide.
So it's 3x.
So 3x plus 1. Very good. Just double check my first times first. X times 3x is 3x squared. That's my first. Last times last. So I'm probably good if I can at least check those, right? To check to make sure it's really truly correct, you're going to have to distribute the whole thing out. Okay, so my numerator is now x minus 4 times 3x plus 1. My denominator is 3x plus 1. Can I cancel anything? Yes, but before I do, just like with my restrictions, let me state my domain. My domain is all real numbers except,
1/3.
is it going to be positive 1/3?
Negative 1/3.
All real numbers except negative 1/3. Think about it like your restriction, right? And then my answer is just x minus 4. How about that? Y'all finished?
No.
It's still going.
Oh, I didn't actually understand.
Press the button, Israeli.